Day 4, Masterclass 2021, Geospatial Applications within Humanitarian Development and Disaster Management by Ms. Ayeisha Sheldon, and Geo AI, which means Artificial Intelligence for Extreme Events by Ms. Salau.
Hi everyone, my name is Ayeisha Sheldon and today I'm going to be doing a presentation on geospatial applications for sustainable development and disaster risk reduction. Please feel free to reach out to me via one of my socials or my website if you have any questions or would like to connect. I hope you enjoyed the presentation. So before we get started, I'd just like to introduce myself. My name is Ayeisha Sheldon and I am Australian and I'm currently living and working in Geneva in Switzerland. I have a Bachelor's of Science majoring in Geographical Information Systems from the University of Queensland and a Master's in Geospatial Science from RMIT. During the past few years, I have been working within the international sector, and in the last 3 years, I have been working in the United Nations system. I am currently working at the United Nations Satellite Centre, UNOSAT, here in Geneva in Switzerland. Today, I'm going to present on 2 topics and some case study examples from both. I would just like to point out that this is definitely not everything on these topics. It's just a very brief overview, especially when it comes to geospatial applications within the United Nations. There is a lot of work being done, and I'm just touching on a few examples where I have experience or have worked with them or I have knowledge of those. So first up, geospatial applications within the United Nations Sustainable Development and Humanitarian efforts. So I'm sure a lot of people already know the United Nations is an intergovernmental organization which was formed in 1945. It aims to maintain international peace and security and develop friendly relations among nations. This is basically to achieve international cooperation and harmonize different actions of nations around the world. The United Nations has evolved over the last years to keep pace with a rapidly changing world, especially when it comes to digital technologies. The United Nations system is very complex and is made up of several different organizations, agencies, funds, and programs. So I'm not going to go deep into the United Nations system today, but if you are interested, it is a very complicated system, but it is also very interesting to learn about how the United Nations does work. So you can check that up online and have a look for yourself. So one of the main agendas adopted by all United Nations member states in 2015 was the 2030 Agenda for Sustainable Development and the Sustainable Development Goals. I'm sure you guys have all seen and heard about the SDGs. They are very popular in today's media, and they consist of 17 goals and 169 targets, which are an urgent call for action by all countries, developed and developing. It aims to form global partnerships and to end poverty and other deprivations and better our world, ensuring to leave no one behind. So you're probably wondering, how does geospatial applications play into the SDGs and the UN system? Well, technology and digital innovations will help to contribute to the SDGs and drive progress and close the gaps. Technology is essential in harnessing the potential to reach the goals between 2030. And technology can help to minimize inequalities by providing access to basic services. Some of these include e-health, online education, e-government tools, and other different initiatives to engage stakeholders and information management. Broadband and internet services can also help to boost connectivity and prevent digital isolation. However, in acknowledging the potential of these digital tools, we also need to recognize the challenges. Digital technologies can drive gaps such as social and environmental repercussions of ICT in the smartphone industry, such as generation of e-waste and other labour conditions. So geospatial applications, they are a form of digital technology, and geospatial applications will be a key contributor to advancing the SDGs. Geospatial services have already been seen to play a large role in our everyday lives and contribute to different activities working towards the goals, from weather forecasting to navigation to disaster mapping to planning to different online activities. These services have a significant impact on all aspects of our everyday lives, and they were actually recognised at the 2018 United Nations World Geospatial Information Congress for their utility in service of social, economic and environmental development. Geospatial information, specifically Earth observation and satellite imagery, is also seeing an increase in cooperation into development planning, leading to more accurate monitoring and evaluation of humanitarian interventions. With more advances in technology, we're seeing faster and more versatile geographical information and spatial analysis, which is becoming increasingly available and accessible, generating more evidence-based data to support real-time decision-making. So with this said, many UN agencies, governments and NGOs are seeing the potential of geospatial and space application data, and they are leveraging it to help within humanitarian and development programs and initiatives already, and I'm sure this trend is just to increase as the years go on. UNGGIM is the United Nations Geospatial Network and leads initiatives within the UN system. Many UN agencies work within the geospatial applications already and within the UNGGIM system and are members of the network. So here on the right of the screen, you can see all of the different UN agencies and secretariat organizations that are already using or going to increase use of geospatial applications. So next, I'm just going to go through some examples of how geospatial data and applications are used within the UN system. I just want to preface this by saying this is definitely not everything. There is so much work done using geospatial applications within the UN system. There are several organizations and examples and really good case studies, but I've just pulled a few of things that I've specifically worked with and that I know about. So definitely do some research if you are interested and have a look. The first example I would like to show is the World Food Programme Hunger Map. So many organisations are using web applications and online databases to share and disseminate information with the general public. This is a great tool for sharing issues and also data and information with stakeholders and other people in a digital, geospatial way that people can understand and interact with the data. So I'm sure you've seen many web applications before. This is just an example of one the World Food Programme has developed to provide information and data on food consumption and food security. You can check it out with the link below. Another example, which I'm sure everyone has seen, is the World Health Organization COVID-19 dashboard. The World Health Organization, among other UN agencies and national governments, have created web applications and dashboards to display COVID-19 data and information. This is just a used case scenario of how geospatial applications can be used within visualization and data dissemination for the general public. Another example of this is the International Office of Migration's Displacement Tracking Matrix. They also use web application to display displaced populations and track them within different countries, which is also in an interactive web-based platform that everyone can access and use. Going more into specific examples, I would like to highlight the United Nations Satellite Centre, which is where I work. UNOSAT is a technical program under UNITAR, which was formed in 2001 and has become a knowledge centre within the UN system, promoting evidence-based decisions for peace, security and resilience using geospatial technologies. In UNOSAT, we work with member states, UN agencies, non-governmental organisations and international organisations to coordinate geospatial activities and development capacities for geospatial information. We work in a range of different fields, including humanitarian, human rights, disaster, conflict, climate, and also, of course, sustainable development. One of the main tasks that UNOSAT does, and that is quite well known, is the rapid mapping team. And the rapid mapping team provides satellite imagery analysis during humanitarian emergencies, both natural and conflict situations. So some examples of this is conflict mapping, which we provided a few months ago during the conflict in Israel-Palestine. And this provided ground field teams with possible damage assessment maps using very high resolution satellite imagery. So these maps and data is all published publicly on the UNOSAT website and is shared between field teams and also other governments and people that are interested in viewing, downloading or using the data. Another example is the Tunisia fires, which just happened, and also a explosion in Thailand. Both of these were mapped using the rapid mapping team. They map all disasters, man-made and natural, and I'll go into some other natural disasters of UNOSAT later in the next section. So UN OCHA is the Office of Coordination of Humanitarian Affairs. They also produce many different maps and infographics using geospatial data to show humanitarian crises and response. They do a lot of mapping with internally displaced people and humanitarian response snapshots in different countries. They also have the Relief website, which compiles all different information on disasters and relief activities, and also the Human Development Portal, which is a data portal which has a lot of really great geospatial data and statistical data on different countries. So you can check those ones out. The United Nations GIS is part of the Secretariat in New York, and they bring together different UN agencies and member states to consider how geography and geospatial information can address global challenges and set norms, policies, and methods. They provide different services upon request, and they form a lot of really interesting reports and publications. They've got the Geospatial Strategy for the UN, the Mapping for Sustainable World publication, and a lot of different other blueprints and strategies of how geospatial information is used or can be used within the UN system and within member states. So then we have the United Nations ESCAP, which is the Economic Social Commission for Asia and the Pacific, and the Space Applications section under the ICT for Disaster Risk Reduction Division in Bangkok, Thailand, also works with geospatial data and space applications. I used to work for the Space Applications section, and it was really interesting work. The Space Applications section uses different geospatial and space initiatives to build capacity and aid member states in the region. They work with space agencies and also experts and member states to help spacefaring countries contribute to non-spacefaring countries, and to help those without a lot of space applications to enhance and to build capacity. So in 2018, the Asia Pacific Plan of Action on Space Applications for Sustainable Development was adopted, and there was a space ministerial conference as well. Since then, I was part of the core drafting team last year to create the Geospatial Practices for Sustainable Development in Asia Pacific Compendium, which is a publication that pretty much just highlights all really good practices of geospatial applications for sustainable development within the region. So I would really recommend going and having a look at this publication. It's very interesting, it's very in-depth, and it shows and highlights really great examples of what's being done already around the region. So now moving on to the second part of the presentation, we're going to now look and dive a bit deeper into a specific field of sustainable development, disaster risk reduction. So disaster risk reduction falls under many different SDGs, but they actually have their own framework, the Sendai Framework for Disaster Risk Reduction. I'm sure many people have heard of the Sendai Framework already. It was the first major agreement of the post-2015 development agenda and provides member states with concrete actions to protect development gains from the risk of disaster. The Sendai Framework works hand in hand with other 2030 agendas such as the SDGs, the Paris Climate Agreement, and it was endorsed at the UN General Assembly following the 2015 Third UN Conference on Disaster Risk Reduction. Pretty much this framework is like its own SDG for disaster, and it advocates for the substantial reduction of disaster risk and loss of lives, livelihoods, and health for businesses, communities, and countries. So this is the framework for disaster risk reduction. It also is So geospatial information has widely been recognised as an important tool which plays a critical role throughout the disaster management cycle. The availability and accessibility of quality geospatial data and information from authoritative sources ensures that decision makers and other concerned stakeholders have an accurate, common, operational picture and critical scenarios before, during and after disasters. Given the inter-regional nature of natural disasters, the SDGs and the Sendai framework have both highlighted the urgent need for countries to work together to increase regional cooperation in disaster management. Many organizations within the UN have utilized space-based technologies to bring relevant disaster information to developing member states. Nations can better implement mitigation strategies if they have aerial or satellite views of where disasters may occur or have occurred. Geospatial information can help to contribute to all aspects of the disaster management cycle. So I'm going to go through some examples of the phases of the disaster management cycle and how geospatial information can contribute, and some examples of how it has contributed in the past. So the first phase of the disaster cycle is planning and mitigation. As potential risks are identified, geospatial information can help to pinpoint hazardous locations to evaluate the risks and consequences of potential emergencies or hazards. Governments can create hazard risk maps using geospatial information to alert citizens and communities so they can better understand which areas are at risk. This is really crucial as building footprints and other infrastructure can be linked with geodatabases to form maps and information about which facilities are more vulnerable or less vulnerable than others. An example of this is the Flood Awareness and Understanding portal for Brisbane City Council in Queensland, Australia. And this is a flood awareness map portal that kind of shows different likelihoods of flood and where flood will go, and to understand the flood better. So if you live in one of these areas, you might need to have some contingency plan, or some backup strategies or something, or to plan in the event that the flood does come into your area. So this is just an example of how governments and local communities can use geospatial information for flood preparedness. For flood planning and mitigation. Moving on to the next step is preparedness. So preparedness includes activities that prepare for actual emergencies, such as the most vulnerable hazard areas, unstable buildings, evacuation drills, escape paths, plans, etc. And geospatial information can help provide answers to questions such as where people should go, where are areas safe, and logistical questions as well, such as how many doctors, nurses are required, how far away they are, etc. So geospatial information can really help within this, and can also help with real-time and monitoring for emergency early warning systems, such as using satellite imagery and weather forecasting programs to monitor weather patterns and earth movements. A really key example of this is a very interesting example from 2019. In 2019, there was cyclonic storm Fanny, which was one of the severest cyclones in the past 2 decades. It hit the Bay of Bengal, affecting 100 million people in South Asia, namely in Bangladesh, India, Sri Lanka. A similar cyclone hit the same area in 1999 and caused more than 10,000 deaths. However, in 2019, the death toll was contained to just 81 people due to the early warning systems, the detection and the robust disaster preparedness and response systems, and accurate weather forecasts that were provided. So this just goes to show how weather forecasting, geospatial information and satellite data can help to prepare people and to avoid catastrophic disasters. The next example is the response. So geospatial information can assist immediately after a disaster by helping decision makers understand the scope of the hazard along with the extent of damage, and identify locations where people may be trapped, injured, vulnerable, or require medical attention or research. Using drone technology or high resolution satellite imagery, analysts can see the damage of critical infrastructure, such as sustainability of health services, food services, or governments that may be damaged or destroyed. Then field and ground teams can be sent in and deployed to the most affected areas to provide help and assistance to those that are in need. So a really great example of response mechanism is the International Charter for Space and Major Disasters. The International Charter is a worldwide collaboration among space agencies through which satellite-derived data and information are made available to support disaster response efforts. The International Charter combines Earth observation assets from different space agencies, such as satellite imagery, and allows resources and expertise to be coordinated for rapid response to major disaster situations. The Charter has been operational since 2000, and since then there has been 725 activations in 129 different countries. The Charter can be activated by different members, and they have different analysts and agencies that work with them to provide the response mechanism. These are some examples of Charter activations recently. The left is a oil spill in Sri Lanka, and the right is flooding and mudslides in Sri Lanka as well. So these are just some of the products that are made freely available on the Disaster Charter website, which coordinate all different disasters when the Charter is activated. UNOSAT, as I had mentioned before, they're not formal members of the mechanism, but they are authorised to request activation, and they do also work within the Charter themselves. So UNOSAT is also activated on their own and part of the Disaster Charter, and they provide on-demand mapping products for different disaster events. So this is an example of a recent disaster and a flood in Bangladesh. You can see on the right, they produced a static map, and on the left is a screenshot of the interactive web map portal, which also shows this data. So these are really key examples of international response for disaster response initiatives. And the main, just to go back, the main kind of aim of the International Charter and the emergency response is to provide member states that don't have capacity to do this themselves. So member states that don't have access to high resolution satellite imagery or analysts or something like that. It's to help those member states to provide them with operational evidence-based analysis and maps and products, which then they can go and use in the field to, respond to the disaster. UN SPIDER, which is the United Nations Platform for Space-Based Information for Disaster Management and Response, is under UN USA, and they also contribute to the Disaster Charter and other space-based information for disaster management and response activities. They ensure that all countries and international and regional organisations have access to and can develop the capacity to use different types of space-based information to support the full disaster management cycle. So they also respond within the they also respond within the Charter. They also produce their own maps. They also work with countries and create products such as knowledge portals, reports, and make data available for different member states. And the last step is the recovery. So geospatial data can still play a role in this step by locating damage and destroyed buildings and to deploy teams for disaster recovery. Geospatial data can also help plan for future and priority tasks if cities or towns need to be rebuilt, or planning or different infrastructure needs to be made available. So with that, that concludes my presentation, and I would just like to end and say that geospatial applications and space-related data has really come a long way. In the last few years that I've worked within the international sector, I've really seen a huge advancement in different agencies and organisations using this data for development. It's a really great tool that has endless possibilities and that can really be used within a lot of different sectors. My passion really lies in development, and I am so lucky that I'm able to use geospatial data within development initiatives to help those in need. And yeah, if you have any questions or you would like to talk or connect with me, feel free to reach out to me. I'd love to chat with anyone, or if anyone wants to know anything or have any advice. I am still in my early stages of my professional career. I have only been working within the international sector for a few years, but I do think during those few years I have learned so much interesting things and all of the different applications of geospatial. So yeah, please feel free to reach out, and that is all. So thank you so much for listening, and I hope that you enjoy your day. Thanks, bye.
Hi guys, my name is Oluwadamilola Salau, and I'm a geospatial analyst. Today I'll be talking about the AI for extreme events. Disasters are common phenomena around the world, and regions of the world experience different types of disaster. Take, for example, in Nigeria, the most common type of disaster that we experience is flooding. And every year, disasters related to weather, climate, and water hazards cause significant loss of life and property. And on the long run, this disaster can lead to a setback in the economy and social development of the region where the disaster occurred. And this has led to a search for solutions on how to reduce the impacts of these disasters. So, what's an extreme event? An extreme event is the occurrence of a value of a weather variable. Take, for example, maybe temperature above a threshold value near the upper end of the range of its observed values in a specific region. Okay, an extreme environment occurs when a weather variable, maybe like temperature, is recorded above the normal threshold. That would be like maybe extremely high temperature can lead to the drought. Then extremely high precipitation can lead to flash floods and the likes. And due to this current trend in climate change, an increase in global mean temperature can lead to extreme events like flood, drought, and heat waves, and they can become more frequent and even more severe. Which is why climate change advocates and climatologists around the world are looking into ways to not only predict when these events will occur, but also predict the impacts that these disasters will have in this region. That's after the occurrence. So, which is why we are all interested in looking at ways to minimize this yearly significant loss in life and property. So, due to this search for solution, there's a new trend in which is due to the advancements in technology. There's a new trend in using Geo AI for extreme events. So what is Geo AI? Geo AI is geospatial artificial intelligence. Is the fusion of geospatial technology and artificial intelligence. So it's more or less like the bringing together or the link between geospatial technology, which is GIS, remote sensing, GPS, GNSS, and the other geospatial technology, and artificial intelligence, is machine learning, deep learning, computer visioning, and the likes. So Geo AI is just the link between geospatial technology and artificial intelligence. So the trend or the emergence of Geo AI is as a result of the increased availability of high quality data, like data from remotely sensed aerial photograph, data from Sentinel-2 with temporal and spatial data. We have geotagged address. We have geocoding of addresses. Then we geotag parameters to location, and even the current trend in using the VGI, which is volunteer geographic information, where people update this data. Then also the emergence of Geo AI can be attributed to the advancements in technology, and also the increase in the development of data-oriented inventions and innovations. This has led to the recognition of Geo AI. So the application of Geo AI to extreme events can be looked at from two different angles, but for the purpose of this particular presentation, I'm just going to look at two. So the first one is the big data and data analytics for extreme events. Big data is like the new trend where we get to look at what we can do with the available large quality data that we currently have in the world. So 80% of the data that we have in the world are spatially oriented. So which are data that have location attributes. So with Geo AI, you can working on extreme event data, maybe like when you are looking at parameters or variables like rainfall, land use type, distance to river, and all like that. Geo AI gives you an opportunity to process this data fast and also in an effective way, where the availability of increased computing capability of Geo AI and the algorithm makes it easy for analysts to just carry out a major analysis on the vast amount of data at a time, which is something that would have been difficult to do a couple of years ago. But right now, with the increased trend in Geo AI, you can work with different climate data, and like it's quite effective when you're working with a large data, and it's easy because a fast analysis would lead to the effective way of deriving insights from the data and also finding patterns. So with Geo AI, you have access to advanced visualization that's showing up your analysis, the results you got from the analysis, and maybe with the use of in Python we use libraries such as Matplotlib and Seaborn for visualization to just show your results instead of using normal charts like maybe bar chart, pie chart in Excel, but with libraries such as Seaborns and Matplotlib, you can have box charts, you can have scattered charts, which have different meaning when it comes to explaining the variables on the charts. Then also, the AI gives you an opportunity to effectively disseminate your data or your results with through the process of development of geoportals, web portals, and all. This is where GIS developers they come in, where they develop geoportals where we display this data for everybody to have access to. And this some go as far as creating an automated process where the data, new set of data that are actually added to this geoportal on a regular basis, where you have updates every day kind of stuff. So that's big data analysis for extreme events using Geo AI. So the second aspect of the application of Geo AI to extreme events is model simulation and prediction. Geo AI gives you the opportunity to develop spatially explicit models useful in predicting the occurrence of an event and the extent of impact of the event, which is the extent of impact of the disaster. So spatially explicit models incorporate the spatial and temporal arrangement of variables such as temperature, rainfall, land use, different parameters for your model. And it takes account for proximity, connectivity, and spatial relationship between these variables. So, and also Geo AI can help you, the result generated from this model simulation and prediction help in developing adequate preparation for the event, development of advanced risk management plans, and even disaster response plan, maybe during the occurrence of disaster. And recent research has shown that spatially explicit models substantially outperform more general models when applied to spatial data. It shows you, this spatially explicit model shows you both the spatial and the temporal parameters of this data. When you're modeling, take for example, you're modeling flood susceptibility with a spatially explicit model. It can show you areas that will be flooded. It can show you the return period of the event. Okay, that's when the event will happen again based on historical data of the disaster occurrence. So this is there's so much you can do with your AI, because even I myself, I can't say I've explored all your AI can offer when it comes to applying it to extreme events. In my role as a geospatial analyst focusing on the link between hydrology and climatology, I use GeoAI to look at return period of a disaster. That's when it will occur, the extent of the disaster, and maybe look into which these results that I get from these models help in looking at maybe coming up with a proposal for risk management plans. And it helps on the long run, it helps in the reduction of loss of life and property cost from a disaster. So a spatially explicit model must satisfy certain requirements, which include invariance tests, representation tests, formulation tests, and outcome tests. Your spatial model must at least fulfill one or more of these requirements for it to be spatially explicit. So we're going to look at the model development stages. So to develop a GeoAI model, a spatially explicit model, there are 4 stages. The first stage is the stage of data preparation, where we have the data collection, data conversion, data storage, data cleaning, and all. Then the stage 2 is when we have the selection of samples from the data you collected, where you get to divide the data into 2, maybe a set for training, another set for testing. So personally, I like to divide my data into 70-30. That's 70% of my data will be used to train my model, and 30% will be used to test my model. But I've seen people who would just choose to use 80% of their data for the training and 20% for the testing. So we need to test our data to show if the data can accurately, or to some extent, maybe 80% predict or even showcase the occurrence of this event, or predict the occurrence of this event, which is why we divide our data into two parts, training and testing. So in the stage 2, you get to train your data, then you look at data evaluation and all. Then in stage 3 is when you develop the model, where you get to select the algorithm that you want to use, algorithms such as SVM, support vector machine, random forest, artificial neural network, different types of machine learning models. And even there's you can get to a state where you use ensembles, where you get to merge different types of data models, machine learning models, to create to improve accuracy of prediction of your model. Then the last stage is the application of a model to new set of data to check if this model can accurately predict this can accurately use this new set of data to predict the occurrence of a disaster or something. So these are the 4 stages of developing a spatially explicit model using GeoAI. So let's just take a look at the example. So this is an example of using GeoAI to develop a model that can look at flood susceptibility of area. So this paper looks at made use of different inputs at 413 flood points, which is basically flood inventory from past events. Then we had the person used 12 flooding influencing parameters, which is called conditioning factors, such as elevation, curvature, aspect, slope, topographic index, and land use, land cover, distance to river, distance to road, soil type, rainfall data, and all. And this particular project utilized hybrid ensemble models such as Darwin, random subspace, which is RS, then with the popular machine learning models such as ANN, random forest, SVM, to just predict if different areas in a region is susceptible to flooding. So he also went ahead, which is the authors, they went ahead to look at the weights of influence of each of these parameters. And looking at this, land use, land cover has a high influence on the occurrence or susceptibility of an area to flooding. So take, for example, an area which used to be forested, and just because we need to, due to the increasing population of the area, there's a reason to convert this forested area to urban centers just to satisfy or accommodate the increasing population. So there can be, which is why land use, land cover can affect the susceptibility of an area to flooding due to the conversion of the natural terrain to from forested to land use, to an urban land use type. So looking at this, land use, land cover had a great influence on the susceptibility of an area to flooding, then followed by distance to road, elevation, slope, and all. Then this is the result of the project. We can see the first one, the A, used the DAGIN, the artificial network model. This was the result of the distance, and this shows the performance of each of this model to predict an area susceptible to flooding in this region. And the results shows that from this particular project shows that the DAGIN model performs more than the remaining models. So this is one thing about GeoAI. You don't just get to use one model, you get to use different models to check which is better in predicting the occurrence of a particular disaster. So for flooding, in this particular area, the best model that had the high performance analysis, after carrying out the performance analysis, so it was revealed that the DAGIN model performed better than the remaining 4 models. You can carry out the same process in another area, and you find out that the random forest might outperform even this DAGIN model. So GeoAI provides you with an opportunity to play around with the different algorithms that you have and look at the one that best predicts the disaster. So that's one of the benefits of GeoAI. So the second example looks at the prediction of extreme dry and wet condition. So this, unlike the first example, which shows us the spatial analysis of areas, this second example shows us the temporal analysis. This shows more like the return period prediction of extremely dry and wet based on historical data and even some of the data conditioning factors like rainfall, maximum temperature, and the likes. So the first one shows you the spatial analysis, while this looks at the temporal analysis. You can have a model that looks at both the spatial resolution and the temporal analysis of the particular parameters you're looking at. So take, for example, if I want to look at the susceptibility of an area in Nigeria to flooding, I can do the first aspect of the modeling, where I look at the areas that are susceptible to flooding, then I can even extend my project by looking at the projection, maybe like return period when these events will occur. So with GeoAI, it's quite limitless. Like for now, because I've been working with GeoAI for a whole year, for more than a year, and I'm still learning new things. So with GeoAI, you get to explore different things where you use GeoAI for traffic counting, use GeoAI to develop flood zones. You can look at rescue zones where after a disaster, where people can move to, like safe zones. So there's so much that GeoAI can do, and I just hope that we keep exploring the opportunities that GeoAI has to offer. So thank you very much for listening.